You just got done deciding if things seem statistically significant or just weird to have happened by chance. So now we're going to do this with z-scores and seeing if the numbers are telling us the same thing. In this class, we just get a basic introduction to how we're going to do this. We are going to decide if something is statistically significant by using a z-score, and this is when it is outside two standard deviations from the mean. The reason that we are using two standard deviations from the mean is, if you recall from before, two standard deviations of the mean includes 95% of the data. So 95% of our data should fall within two standard deviations of the mean, making us 95% confident. If I'm 95% confident, that is pretty good. You'd be very, very happy with that. It's kind of like a solid A. There's only a 5% chance that we're wrong. If we did one standard deviation, I would say that I was 68% confident, and you would not be very happy with that. 68% confident does not show a lot of confidence in your decision. So we go with two standard deviations. You can do more, but in this class, we're going to stick with that level, that typical percentage of 95%. So what we do is we look at that normal curve and we say, okay, that 95% marks off those two standard deviations. 95% is a number that makes us really, really, really happy. If we happen to have a sample that falls outside of two standard deviations from the mean, that's when we say that it is statistically significant and it could not have occurred by chance. So, when we're rolling a die 200 times and we only get 5 2s and all of that. That seems very, very unlikely. So we would be concerned that that die would be weighted. So these are the kinds of things that we're looking at. Now, the topic that we're going to talk about today is a lot more complex than we have time to cover in this class. That's something that we save for a statistics class. So in this class, we have to assume that we're looking at a normal population because we're really using something called the central limit theorem. So we're not going to talk about that today, but our z-score is going to look a little bit different. And this is because we're looking at a sample and how that compares to a mean. So we're looking at a certain sample size now, where we're looking at a group of individuals and we're seeing how their mean compares to the mean of the population and how do they compare in numbers of standard deviation. One way to look at it is thinking at, before we were only looking at one individual compared to a group, and now we're looking at a multiple. So if your n value was 1, we would end up with our z-score formula. And, that's just one way to look at it, but it is a bigger topic than we're going to have time to talk about in here, which makes me sad. But if you do find this stuff interesting, definitely think about exploring one of our stats classes. So we're going to look at this basic z-scores. So let's look at the first example. So here we are looking at Doritos. Okay, so all this data is just made up, but we want to know, are we being ripped off? So the Doritos company claims a small bag should contain 12 chips with a standard deviation of 1.4 chips. So when you open up that bag of chips, you're going to get 12 chips. However, from a sample of 12 bags, the mean was only 11.2 chips. Are they ripping us off? I thought I was going to get 12 chips and I only got 11.2. So we're going to find the z-score. And now we're looking at a group of 12 bags with a mean of 11.2 and seeing how that compares to what we would expect of 12 given the standard deviation of the overall group. So we're going to go ahead and we're going to write down our givens. Now, this is a lot of information to look at the beginning. So let's make sure we can get our different pieces of information. So X bar is at 11.2. So that is our average from our group, or our sample, which was the 11.2. Then we move on to the standard deviation. Now we are assuming that we know the population standard deviation. It tells us that it is 1.4. Mu is the average for the group. This is what Doritos is telling you is in the bag. It's telling you that there are 12 chips in the bag. So this is referring to this 12. There's two 12s in this problem. So that's how many chips you would assume that you're getting. And then n is your sample size. So here we're looking at a sample of 12 bags. That's your number of bags that you're looking at. So what we're going to do now is we're going to say, okay, well, we got a low number of 11.2 chips on average. Is that statistically significant? So 11.2 may not seem that far from average, but let's see how that comes into play here. So we're going to go ahead and find the z-score. And we're going to do that using the formula from above, x minus mu over sigma over root n. Remember, once again, we're using that root n because now we're comparing a sample to a population and we're looking at a mean. So if you do this formula all the time from what we did before, you could use n as 1 and you're going to get the same thing. Talking about differentiating between which formula to use when, that's something that you'd really dive into more into in a different statistics course. So now we're just going to go through, we're going to plug in all those numbers. So we have 11.2 minus 12 over 1.4 divided by 12. Plug that into your fancy schmancy calculator and we get negative 1.98. So let's decide if that's statistically significant. So when we look at our conclusion, we have our normal distribution. We have my green dotted line here is the line that represents 2 standard deviations from the mean. Remember that if we are past that, if we're over here, that's the stuff that's so far from our average of what we would expect that we say that it's statistically significant. So we're over here at negative 1.98. So we did not make it to that line. We are not statistically significant. We didn't make it past that boundary. And so, yes, we're really, really close to it, but it doesn't matter how close you are. If we're not at that 2 standard deviations away, then it is not statistically significant. So we would say something like this is not statistically significant because we are not over 2 standard deviations from the mean. We just happen to get an unlucky sample of Doritos. So we got that bag, that pack from the grocery store that just had a few chips less than average. But overall, Doritos is not underfilling their bag. So now what I want you guys to do is I want you to go ahead and just use the formula that you have above, read through this next problem, and I want you to try it out. When you are done trying it out on your own, then you can go ahead and press play and I will walk you through it as well. Okay, so hopefully you just had a chance to read through this and try it out on your own. If not, now's your chance to pause it and try it. So this one's about Jimmy John's, once again, made up data. They say they're so fast they're free because they'll have your food in 10 minutes delivered with a standard deviation of 1 minute. However, in a sample of 8 orders, we have a mean delivery time of 12.2 minutes. Ooh, so that's quite a bit longer than 10 minutes. Is it statistically significant for us to believe Jimmy John's is inaccurate with their claim? So here we go. So first we go through and we make sure we have all of our given information. So X bar is that sample standard deviation. So from our sample of 8, what was our mean time? So 8 orders, our mean was 12.2. So that 12.2 is our sample average, how long it took our 8 orders on average to be delivered. Standard deviation of 1.1. Jimmy John's is claiming this is the true population. We're believing it should be 10. We had 8 orders. We go through, we find the z-score, and you should have done this already. So you should be able to just compare. So I'm going to go through it fairly quickly. So we go through, we plug in all of our values, and we get 5.65 standard deviation. When we take a look at that, this is statistically significant. Once again, my green line is showing you that 2 standard deviations from the mean. We are so far past that. So we are in that statistically significant region where we're so much greater than 2 standard deviations from the mean. This is so unusual to have happened by chance that we think that Jimmy John's is truly taking longer to deliver their food than they're claiming. So once again, we're comparing. If we are past that boundary, that's telling us, yes, it is statistically significant.